So now to continue with part B, we're being asked to find the magnetic force per meter on wire 3, so that wire over there. The first thing I'll do is I'll draw the net magnetic field vector, and I'll erase a few things. So we have a positive I component and a negative J component. So positive I and then negative J. So our net magnetic field would also point down. So what this really meant was that B2 was actually stronger than B1, hence the net magnetic field ended up being downwards. Now to find the magnetic force per meter on wire 3, we used the formula from the magnetic field chapter. This doesn't mean anything, it's just a notation. So basically I'm talking about this formula. F is equal to IL cross B. I is the current in the third wire. The net magnetic field is the net magnetic field on the third wire. And then L3 is, of course, the length of the third wire. Again, don't be confused by that. That's just the way the formula itself usually is represented. Well, technically, there's another formula. This one right here. It's represented this way, F over L. But our formula from the magnetic field chapter is represented this way. So actually what I'll do is I'll get rid of the L in the denominator, just to make it easier for you to understand and you don't get confused. But the L is just a notation for the other formula I showed you. It doesn't have more meaning than that. It just means newtons per meter, so force over a unit of length because of the radius between two wires. And now for this formula, we basically have the net magnetic field. That's awesome. We also have the current in the third wire. And then we just don't have L3. The thing with the length of the third wire is that it's an infinitely long wire, so it's technically infinite. But that doesn't matter. Here in the cross product, all we really need to do is to say that there are actually two definitions of the cross product, right? There is the following for this equation: the magnitude of the length, the magnitude of the net magnetic field, and sine of the angle between them. And then the other definition is where you actually do the cross product, like using the unit vectors. So that's all we're kind of going to do. We're going to use unit vectors instead of actual values, at least, well, for the length. If you want a more thorough explanation for this, it's better to go ask your teacher. I haven't fully understood the whys behind this myself. So we know that the current in the third wire is pointed towards us. If your tablet is flat on the table and you're watching this on your tablet, the current in the third wire is pointing towards the roof into the positive K direction. So we do the following. I3 was 6 amperes times positive K hat, that's the direction of this guy, crossed with the net magnetic field. Instead of plugging in the values of the net magnetic field, I'm just gonna deal with the components first, just the i's and the j's. So it's I minus j, like that. So what I will get is k cross I. If I do k cross I get positive j. So I'll be getting a positive j hat. And then k cross minus j, which is going to be positive I hat. So positive I hat and positive j hat. That's what I'll get as an answer. Now I'll actually show you the entire formula with the numbers. This is still going to remain positive k hat because we don't need the number. The actual, it's just infinite, so it doesn't really matter. Again, to get an explanation on that, it's better to ask your teacher. And then we plug in the actual values here, which is 2.67 times 10 to the negative 6 in the I hat direction. I'll make my writing a bit smaller for you so you can see everything in a one straight line, and then it's minus 3.08 times 10 to the power minus 6 in the j hat direction. And of course Tesla for units. So we kind of already did the unit vectors, we handled them, and we handled that negative sign. So now it's just a matter of multiplying this guy is being multiplied by 1. So we're doing 1 times 2.67 times 10 to the negative 6. Okay. Which is going to give me the same answer, 2.67 times 10 to the negative 6. And then I'll multiply it by 6 amperes to get the actual I hat value down here. And I'll do the same thing there. Again, don't be too confused by this. It's just a 1. You're just multiplying by 1 here for the positive k. It doesn't really make a difference. So what you're really doing is you're multiplying 6 amperes with this guy and 6 amperes with this guy. That's it. And then you get your actual final answer. I'll put this in the calculator to make sure I've solved it right. So we're doing 6 times 2.67 times 10 to the power negative 6. That's for the I hat unit vector. Which gives us this. And then 6 times negative 3.08 times 10 to the power minus 6. Which gives me the following. Remember that negative sign is already gone because we did the, I just remember that. And this is newtons per meter. So the only problem I've encountered is that I have my components swapped for some reason. Let's see. And that actually makes sense. So, and what I had written initially was actually J and I. That's what happened. And what I did was I erased these two and I swapped them basically. So initially I wrote them like this, which was the correct order. But then where I messed up was that, so I'm multiplying 6 amperes with this value of the I hat component. That would give me the J hat. Okay. Now I swapped them after when I wrote them. So then that's why I got the values like placed in the wrong order. But yeah, like everything is correct. Don't worry. Um, that was pretty much it. So basically, this is J hat, and this is I hat, and yeah, the answer is correct. We have the correct answer. So that's pretty much it for this problem. There's nothing more than that. Again, the main issue with this problem was just for part A, to get the net magnetic field, you need to just be careful with the angles. That's it. That's the main thing to really focus on and perhaps review. Let's say you don't have enough time to study for a test that's going to have a question like this. Just keep in mind that for specifically a question like this, you need to just know how to find the angles. The rest is a bit like not too difficult. It just depends on you and what your weaknesses are at the end of the day. But that's the main idea. I hope this helped, and have a good day.